All right, so for this problem, we see we have 1 over 1 plus secant x squared. And the first thing we've got to do is figure out what rules are we going to need to use. You know, it's kind of like envisioning a road map through this problem. How are we going to approach it? So which rules do you see us potentially needing to use? Yeah, so one possibility, quotient rule, because I see a big old fraction there, so we could be using quotient rule. Okay, what else might we end up then needing to use? Yes, chain rule. Chain rule could come up on this one because you notice that inside the squared I have another function. And so that would be an inner part and the squared would be an outer part of that function. So yeah, we're going to need chain rule as well. Now, personally speaking, I'd rather not have to use quotient rule and chain rule if I don't have to. And actually you don't have to on this one. And that's a little trick I want you to see that you have at least as an option if you want it. Because f of x could actually be rewritten here, because it's just a 1 on top here, I could rewrite this as 1 plus secant x to the power of -2. That is the same thing. If I rewrite it like that first, I only need one of those rules now. Which one did we just get rid of? Quotient rule. So you actually have a couple options about how you approach this problem. You can use quotient rule and then combine chain rule with it. Or you can just use chain rule if you first start by rewriting it with the negative exponent. Now personally, I think it's a little bit easier to do the latter. So go ahead and please find that derivative now. Alright, so to find f prime of x, we now need to use chain rule, which means I start by doing the derivative of this something to the -2. That's the derivative of the outer. So that means power rule, which by the way, we didn't actually list as one of our rules we need to use here, is we actually do have to use power rule. We just take it for granted as being such a straightforward thing. We sometimes don't think of it, but yes, we are using power rule here. So we do -2 times that something to the power of, and then I take my original exponent, subtract 1, so it becomes a -3. The stuff that's on the inside, where normally we just have an x, it just stays whatever it was. But this is where the whole chain rule thing comes in, because I now have to multiply that result by the derivative of the inside. So the derivative of secant is secant tangent. And so then that gives us our answer. And yes, you're fine to leave it like that right now. All right, and so we start here by again figuring out, okay, what rules are we going to have to use? We're kind of strategizing ahead of time. All right, so for doing this one now, we got to figure out what rules are we going to use. And the first thing I want you to see, the first thing I want you to be very aware of, is that with this plus in between, really we're taking two different derivatives. We're taking the derivative of that sine of e to the t, and we're taking the derivative of this e to the sine of t. Each of those are done separately, because remember, anything separated by addition or subtraction, we just take each of those derivatives separately. Makes our lives a little easier. All right, so for the sine of e to the t, what rule am I going to need to use there? Chain rule. I see chain rule, yes. Because in doing this one, it's not sine of x, or sine of t. It's sine of a function. So it's sine of e to the t. So that means that this e to the t is going to be the inner function, and then sine's the outer. Okay. And it looks like that will be enough. So for the first one, it's just going to be chain rule. Okay, for the second one now, e to the sine of t. What rule am I going to need to use there? Well, it looks like maybe chain rule again. What's the inner function for this second part? This is the part that sometimes we have trouble with. Yes, you're right there already. It is the sine of t. Always think about, where does the x normally? Normally, if it's e to the x. Well, in this case, it's e to the sine of t. So sine of t is what's now inside instead of the x. And so that tells us our inner function. So yes, this one is also chain rule. So this will require two different implementations of chain rule. Nothing else. Okay, so now that we've kind of seen where to go with it, go ahead and go there. Find that derivative. All right, so to find f prime of t for this one, I'm first going to do the derivative of sine of e to the t. So for that part, I first do the derivative of the outer function, which is derivative of sine. Derivative of sine is cosine. So that's going to be cosine of e to the t, because we just leave whatever was inside, and then I multiply it by the derivative of the inside. So that's the derivative of e to the t, which is e to the t. It's its own derivative there. And then we hit our plus. All right, and now we go the other way. So now I'm going to do the derivative of e to the sine of t. All right, so first up, derivative of the outer function. The outer function here, our starting function, our basic function that everything else is built on, is the e to the x kind of part. So this is going to be e to the power of sine of t, because again, it's its own derivative. And then I multiply that by the derivative of the inside function, which is the sine t. Derivative of sine, remember we just talked about being cosine, so it's going to be cosine of t. And yes, we could maybe reorder it a little bit just to try to make it look a little bit cleaner, but really this is a good answer right here as it is. So, final answer. Call it good. All right, now as I take a look at this function, all of a sudden I see something that maybe I don't like quite as much. Because what rules are we going to need to use? Yeah, I see product rule already right at the start, because I see where this parenthesis cubed is being multiplied by this parenthesis to the 6. So I already see product rule being used there. Now looking within each of those two parts of our product, what rule am I going to need to use? Chain rule. Yeah, chain rule. Because there I have some function within another function. More specifically, I have this x squared plus 1 that is being cubed. So our inner function is the x squared plus 1, and our outer function is the something cubed. And then for the second part, same kind of an idea, where the x squared plus 2 is my inner function. Actually, let's go the same way with that. And then the something to the power of 6 is my outer function. And so for both of those, I'm going to end up needing to use chain rule. And we're going to put them all together. So, now it's time to try this out. Go ahead and now try to find the derivative of this function by combining chain rule and product rule, please. All right, so we now need to find this using a combination of product rule and chain rule. Now, to make things a little bit easier to kind of follow here, I'm going to just go ahead and color code this just to make it stand out a little bit more. So I'm going to make this first function, I'm going to write that one, everything having to deal with it, in black, and I will do the other one in red then. All right, so for product rule, it means I have to do the derivative of the first function times the second function, plus, and then I go from there, but let's just do the derivative of the first function first. So that means it's going to be 3 times something to the power of 2. And that something is whatever was originally inside the parentheses. And then that is now times the derivative of the inside, which is 2x. So this is just derivative of this function here using chain rule. So derivative of the outer function, that is the something to the third, gives me the 3 in the power of 2. And then times derivative of the inner function, derivative of x squared plus 1 is 2x. So that's the chain rule part for that. But now I go back to product rule, which means I multiply the derivative, which I just found, times the original of the other. So that's the x squared plus 2 to the 6th. All right, that's the first half of product rule. Now I go to the second half of product rule, which is the first function exactly as it was, so x squared plus 1 cubed, times the derivative of the second function. So chain rule, becomes 6 times the x squared plus 2 to the power of 5. And then that is then multiplied by the derivative of the inside, which happens to, again, be 2x. Now that is our derivative. That is done. That's fine as our answer right now. Now I say right now because, yes, we could try to clean it up maybe a little bit, but there's not a ton we can do. But I do like to always talk about how could we clean it up if we're pushing for that. So then, what can we do? Well, really, I can just be multiplying those integers by those 2 x's in there, because I certainly do not want to have to multiply out those exponents. So if I did clean it up, I would have a 6x in this first one, and that's times whatever was originally there. So x squared plus 1 squared, and so on. Then that's plus. Then the 6 times the 2x there gives me 12x. And then again, same stuff as before. So if I want to push things a little bit and just work on cleaning it up, this is what I'd be looking at. But again, did we have to go there for it? No. But it's good to see, okay, what can we do? And even really, not so much even just what can we do, but what should we do? Because notice I don't have to multiply out all those exponents, because that would just create a really long and crazy polynomial, right? And we just don't want to have to deal with some of that mess. Plus, it makes it more prone to error, which is never good. All right, and with this function, once again, we're going to start by kind of that strategy session, figuring out, okay, what am I actually going to need to do in order to figure this out? And what I see as I take a look at this, I see an e to the power of something function, and I see a cosine function. That's what leaps out to me first as I look at it, is I see 2 different functions, and those 2 functions, they're being multiplied by each other, which automatically tells me product rule again. So just like the last one. So this one actually, the initial setup in some ways is just like that last one, where I have 2 functions multiplied together. It's just in this case, they're not just nice, pretty polynomials. I have one exponential and I have one trigonometric. But same idea. All right, now I'm going to look at each of those 2 parts separately and see, is there anything else I need to do here? So for the first part, the e to the negative 2t, am I going to need any special rules to figure that part out, like chain rule or anything like that? This one sometimes actually gives us a head scratcher in answering that question, though. Especially the e to the power of something. It's normally e to the power of x, or e to the power of t, right? But it's not here. And so because that's a negative 2t, it's actually going to be chain rule, where this negative 2t is the inner function, and the e to the power of that is my outer function. So I'm going to need to use chain rule there. All right, and then taking a look at the second part there, the cosine of 4t, am I going to need any special rules there? Like, will I need chain rule on that one? Yeah, it looks like we will. If it was cosine of t, we'd be okay. We wouldn't need any special rules. But it's not cosine of t, it's cosine of 4t, which means we have a function within the function. Even just putting that constant inside with it makes it a different function. So my inner function then is going to be 4t, and my outer function is going to be the cosine of that. So once again, chain rule. All right, now we kind of strategize, seeing what we're going to need to use. Use it. Go ahead and find that derivative, please. Once again, I'm color-coding the 2 sides to my product rule here. So in this case, I'm doing the first one in blue and the second one in red. So if I'm going to use product rule, that means the derivative of the first function times the second function to start with. So that means I got to start with derivative of e to the negative 2t. So I am going to need to use chain rule for this. We already talked about that part. So that means derivative of the outer function, derivative of e to anything is e to that anything, times the derivative of the inner function. So now I do the derivative of the negative 2t. And derivative of negative 2t is negative 2. Alright, so that's the derivative of the first function. And product rule says I multiply that by the second function. Just the second function as it originally appears. Alright, now plus, and we flip which one we're taking the derivative of. So the first function stays the same now this time, so it stays e to the negative 2t. No derivatives or anything to have to worry about there. And then we do that times the derivative of the second function. Now, derivative of cosine of 4t, yes, we have to use chain rule here. So I do the derivative of the outer function. So the derivative of cosine is negative sine. So it's going to be negative sine of the 4t. And then that is times the derivative of the inner function. So then that's times the derivative of 4t, which is 4. And in terms of getting the derivative, that is your derivative. That is your derivative function. And so you are fine to stop there and go ahead and leave that as your final answer. Now, looking ahead again, how could we or would we simplify it? I would probably just pull those numbers out front and the negatives out front, basically. Right, now this problem is the problem that when it first appears tends to cause people to groan or run and hide someplace. Mostly just because square roots tend to seem a bit intimidating to us on this. But it doesn't have to be. We can deal with this using all our rules. Let's just start picking it down, strategizing how are we going to deal with it. So first up, as I take a look at it, what rules will I need to use? Well, yeah, the first one that usually leaps out to us is that because I have this fraction here, I'm going to need the quotient rule. So yes, we are going to have to actually use the quotient rule here. But notice that that fraction that I got to use quotient rule for is inside of a square root. And since it's inside of the square root, it's inside of another function, which means we need to use the chain rule. Absolutely. So the whole thing then on the outside ends up being an application of chain rule. And yes, we will have to use both of those. Now, just looking ahead, a reminder, because I know the square roots are the ones that tend to give us trouble. If I have the square root of something, let's just make up something. Let's call it the square root of u. I always like to use u for that sort of thing. That would be the same as u to the power of what? 1/2. 1/2. And so when I go to actually find this one, find the derivative, basically the first step, start by writing the whole thing like that with the 1/2 power, and then go from there. Alright, so let's go ahead and find that derivative now. So you notice that between the two parts there I have a chain rule and I have a quotient rule. Notice that the quotient rule is basically inside of the chain rule part, because my fraction is inside of the square root function. So the chain rule being kind of that outermost piece of this, the chain rule is basically the part that I start using first. So to use chain rule, that means derivative of the outer times derivative of the inner. So derivative of the outer first, and the outer is that something to the 1/2. So that means I'm using power rule. So I do 1/2 times something to the power of 1/2 minus 1, which is a negative 1/2. Now what is that something? That something is whatever was on the inside of the fraction, or inside of the parentheses to start with. So that's the s squared plus 1 over s squared plus 4. Now that's the first part of chain rule. The second part of chain rule is derivative of the inside. Now derivative of the inside though here means quotient rule. That's where we have to apply it. So now we remember our quotient rule, which yes you do have to have memorized, which a good way to memorize it, start with low d high. That is the low function, the bottom of the fraction, so that is s squared plus 4, times d high. That is the derivative of the top. So the derivative of s squared plus 1 is 2s. So it's low d high minus high d low. So high, the top, is s squared plus 1. And d low, that's the derivative of the s squared plus 4. Derivative of s squared plus 4 is, again, 2s. And that is all over the square of what's below. So that means take whatever was on the bottom at the start, s squared plus 4, and square it. And that's the derivative of the inner function. And because we did derivative of the outer times derivative of the inner, we are done. And no, I'm not going to worry about simplifying this right now.